So for lesson 3, we're going to be dealing with area. Before we begin, who can tell me what area is, or what keywords come to mind when we think of area? Alex. Okay, be more specific. Inside of what? Say it again. Remember, cube is what? Cube, okay. Cube is what? Volume, because it's what? Okay, so remember, area does not deal with 3 dimensions, right? Area deals with what, ladies and gentlemen? 2 dimensions. So it's very important, which means that once we find the area, it always ends in what? Squared. Whatever measurement squared. So, continue. There we go. So, perfect. It's the space that fits inside of a flat shape. Okay? What flat shape did we already learn how to do area for this chapter, ladies and gentlemen? Circle. So you guys should have that formula down. Who wants to be brave enough to raise their hand and tell me what the formula is for the area of a circle? Sophia. Okay, so remember, we're always going to start with area equals. So say area equals, and then it'll be pi times radius squared. Pi meaning what number, ladies and gentlemen? So you remember, you put 3.14 in the calculator, and then radius being, who can define what radius is? Jaden. Okay, so the diameter of the circle divided by 2. For those of us that don't know what diameter is, what's diameter? No, I didn't call on you. Olivia. The line that goes through the entire middle of the circle. So, reviewing area of that, and again, see, you guys are noticing the thing does not want to work right now. There we go. So here's my circle. Diameter is the line that goes through the direct middle of the circle. The radius is half of that. So if you know the diameter, you should be able to find the radius by dividing it by 2. If you have the radius, you should be able to find the diameter by multiplying it by 2. Remember, with area, we want the radius. Diameter comes into play when we want to find what? Who remembers that? Because this is also going to be part of this chapter. Diameter is for what? Jaden E. You need to give me a ticket. Anybody? What's the diameter used for with a circle? The circumference, which is again is like the perimeter of a circle. That would be pi times diameter. So for area, again, it's pi times radius squared. Area equals pi times radius squared. And remember, due to PEMDAS, we do exponents first. So whatever the radius is, we square that first. Do not make the mistake of doing pi times the radius and then squaring that answer, because it'll be completely wrong. You have to square whatever the radius is first. So let's say the diameter here equals, let's say, 8. Let's do 8 centimeters. What would the radius be? Because I need the radius. Ladies and gentlemen, what would the radius be? 4. It's not the area yet. Remember, we have to have the whole thing. 4 is part of it, but what's the other part, ladies and gentlemen? Centimeters. We need the measurement. So what this would be is then pi times 4 squared. 4 squared is what? What's the same thing as saying 4 squared? 4 times 4. Remember, when you square something, you multiply it by itself. What is 4 times 4, everybody? So this would become pi times 16. And then again, we use our calculators to do that. Pi being 3.14 times 16. The area of this circle would then be area equals 50.24 centimeters. And ladies and gentlemen, what's the last part of my answer? Squared. Because it is the area. Area is always squared. Therefore, I found the area of my circle. This is something you guys need to have from the beginning. So, the difference between what we're doing with this one is, I'm going to show you guys right now. Actually, bookmark circle, because we're going to come back to circle. So, we're going to go over what a composite figure is, because this is what we're dealing with. So we're still dealing with area. Again, area will always end up being squared. Ticket. Whatever the measurement is, So again, the number, the measurement, and it being squared. So if it's like 3 inches squared, 5 centimeters squared, whatever, remember area is always going to be whatever the number is with the type of measurement, and it's going to end up in squared. Area will always be that. So the area, again, is the space inside of a shape. You guys are going to be dealing with multiple different kinds of shapes. The shapes that you guys are going to be dealing with are this. I have base times height. My AMP up class cannot answer any of these questions because you guys got this already during AMP. What shapes would be base times height? What shapes would be found with base times height? Brian, what do we think? When you look for area, base times height, what shape? Wesley, you want to help him out? Okay, square is one of them. That doesn't look like a square, but let's pretend that's a square. What else? That's the rare one. Parallelogram. Parallelograms usually look like this. Same exact thing. And the last one? Rectangles. You're in my AMP. You should have answered. So, base times height. Base referring to the bottom line of the shape. And the height referring to how tall it is. With a square or a rectangle, it's usually just the opposite side, because there'll be a little right angle there. With a parallelogram, it's a little different. Parallelogram, you'll either see the little dotted line with the right angle, or you'll see something like this saying the from the top part to the bottom part, this little line on the side here, telling you how tall it is. You just need those two measurements. You multiply them together, and there's your area. The reason why a parallelogram also follows this is if I were to cut this part off, this part here, and I put it right here, it would form a rectangle again. So this is why parallelograms follow the same formula. So again, squares, rectangles, and parallelograms will all have the formula of base times height. Who knows what the formula for this is? 1/2 times base times height, or base times height divided by 2. What shapes is that formula for? I know you know. I'm trying to see if anybody else knows. So we went over this last chapter. Adrian, what is it? Triangles. And it doesn't matter what type of triangles. Right triangles, acute triangles, obtuse triangles, it does not matter. It's always going to be base times height divided by 2. Base, again, referring to the bottom portion of the shape. And then the height determining how tall it is. With this being a right triangle, it's going to be this side. And with this not being a right triangle, it's usually going to be indicated with a little dotted line, or even something like this again, showing how tall it is. So you need the base and the height in order to find the area of a triangle. And then circles again, to recap, is pi times radius squared for the area. Now I'm going to bring back where we bookmarked. The reason why I bookmarked the circle is when you have a composite figure is a figure made up of 2 or more shapes. So let me give you guys an example. Here's like a little kindergartner's example of a house, right? What shapes is this made out of, ladies and gentlemen? Triangle and a? That's not a square. Okay, real side note. Do not assume anything is ever a square until you know what it is. Always assume it's a rectangle. Until they tell you these 2 sides are the same, or all 4 sides are the same, then just assume it's a rectangle at first. Once you get that it's a square, then you know it's a square. So, 2 different shapes, 2 different formulas. For a rectangle or square or parallelogram, it's base times height. This one would be base times height divided by 2, or 1/2 times base times height. Either one of those works, because again, when you multiply something by 1/2, it's the same thing as dividing it by 2 anyway. And I'll go back to the triangle example here in a little bit. So this is a composite figure. Again, this should be in your notes. Composite figure is a figure that is made up of 2 or more shapes. We just said it needs to be in your notes. A composite figure is a figure made up of 2 or more shapes. Again, a composite figure is a figure made up of two or more shapes. When you guys are done, when I'm done teaching the lesson, if you guys look at your OneNote, you will see here there's the definition, and these are the formulas you're going to want to get to. And there's one formula that I did not go over yet, and that's trapezoid, but I'll get there. Now, the reason why I bookmarked the circle thing is when you deal with composite figures, circles are going to show up, but circles are not going to show up as a full circle. This is an example of a composite figure where you're going to see this. It's called a semicircle, or better yet, half circle. You need to know how to find the area of a circle because guess what? When you deal with something like this, you need to do what to that area? If that's a half circle, what should I do to the area, ladies and gentlemen?
Times 2.
Not times 2, that's double it. Divide it by 2. So find the area of the circle like normal and divide it by 2. Now, let me give you this. Let's say that this rectangle is 12 by 4, and we'll say inches. Now, you have the base and the height of the rectangle, so you can find the area of the rectangle, right? Do you have everything you need for the circle? You should. What do I need to find the area of the circle? Again, ladies and gentlemen. Radius. I don't have the radius, but do I have the diameter?
Yes.
How do I have the diameter? Oh, I did not say ladies and gentlemen. Shalom, thanks for raising your hand. There we go. We're using, good job, good academic vocabulary. Congruent. With a rectangle, parallelogram, square, the opposite sides are equal. So if this side is 12, right here, the base, that means this side is also 12. This side 4, this side is also 4. So that means our diameter for our circle is 12. I don't need the diameter though, I need the radius. And again, what's the rule of the radius? The radius is always what of the diameter, ladies and gentlemen? Half. So what's half of 12, everybody? 6. So my radius here is 6. So let's find the area of the square first off. 4 times 12 would be the area, right? Clear your calculator. 12, unless anybody knows what 12 times 4 is right off the top of their head. 48. So the rectangle's area equals 48 inches squared. And this is a rule that I always do. I write inside the shape so I know that I already counted it. I found it so I don't double it or accidentally leave it out. Because when you have bigger composite figures, you're going to have more than 1 or 2 shapes. You're going to have like 4 or 5. So it's easier for you to just write on the inside, I found it. Now I need to figure out the half circle. Remember, it's a half circle, but I still need to figure it out like it's a full circle. Once I figure out the area of the full circle, I just divide it by 2, right? So this is pi times radius squared. Pi times, and my radius was 6 squared. What's 6 squared, everybody? Well, I heard someone say it. I said everybody. 36. So this will be pi times 36. Remember, you have to square the radius first. So, clear. 6 times 6 equals 36. Times pi, which is what, ladies and gentlemen? 3.14. There's the area of the whole circle. However, I have half a circle, right? So what do I need to do now? I did not say ladies and gentlemen. Ariel. Let's divide that by 2. My half circle area is 56.52. Area equals 56.52, and this is inches squared. But the question asks for the area of the composite figure. I need to add those two areas together to give me the whole area of this. So I already have 56.52 in the calculator. What was the area of the rectangle again? So let's add 48 to it. And this is where I kind of indicate this differently. I'm going to put TA for total area, because it's a total area, will equal 104.52 inches. And what's my last part? Squared. And there is my answer. So I found the area of the composite figure. You find the area of each individual shape. If you see something like this right here, that is a semicircle, which is the same thing as half a circle. Those will show up on your composite figures. Very rarely is a full circle going to show up on your composite figures, because remember, composite figures are like usually attached to each other. A whole circle that has no flat sides, not going to attach very well to a composite figure. And if I'm going too fast, remember this will be uploaded immediately after this, so you guys can rewatch it. Now, the last thing we need to go over is the area of a trapezoid. Now, for your quizzes, you're going to definitely want to have every formula memorized. And I'll tell you guys right now, yesterday, I did not have trapezoid memorized. So, even the math teacher didn't know the area of the formula for the area of a trapezoid by heart. You guys are going to need to study, and you guys are going to need to review your notes, Mr. Pastor. Yeah. Okay. Bye. You can't be texting during school. You have to go to the office to let them know that you don't feel good. Okay, so I guess somebody's coming, so you gotta go. Don't do that again. Okay, so trapezoids will look two different ways. Trapezoids will normally look like, and again, it's doing it. Yay. Love technology. Good stuff. There we go. This is the normal trapezoid that you guys are used to, right? Trapezoids can also look like this if it'll let me do it. Nope, it'll keep fixing it into a dang triangle. So, love technology. That was not even close to a semicircle. Okay, so trapezoids can look like this where they don't have two slanted lines. Trapezoids can look like either one of these. The area for the formula for the area of a trapezoid is area equals 1/2 times the height times base 1 plus base 2. Now, let's go over what each of these means. Base 1 and base 2, it doesn't matter which one you label as which, but they're the two flat sides of your trapezoid. So, for example, let's indicate base 1 with blue. So base 1 would be like the top. And base 2 will indicate with green. Base 2 would be the bottom. Now, if you mix and match them and accidentally say base 1 is the bottom and base 2 is the top, it doesn't matter because you're going to add the two together before you do anything. Okay? So it really does not matter which one's base 1 or base 2. Just identify what the two bases are. It's the two flat sides that are opposite from each other. The height is how tall the shape is. So again, with a trapezoid like this, you will have something like this. Or if it's a right angle trapezoid, the height is literally that side. And then again, it can also be determined with something like that, and it tells you how tall it is. So you need the height. Now, with it being 1/2 times base, or 1/2 times height times base 1 plus base 2, you can also say this, or it is area equals height times base 1 plus base 2, and then divide it by 2. Either one of those works. I'm going to show you how I would do this just to make it easy. So, yes.
Wait, so on that kind of trapezoid, height will always be 90 degrees or just some?
If it's a 90-degree angle, the height will always be this. If it doesn't, then it'll indicate something like this. Okay? Height will always be identified with a 90-degree angle somewhere. It has to be identified with a 90-degree. Either if it's on this side right here, or if it's in the middle, because you see here, 90-degree angle, it'll always, even with a triangle, it has to be a straight line up and down. Because like when you take your height, you don't like lean and then they measure you, right? You stand up completely straight. You're forming a 90-degree angle with your feet on the ground. So that's how we measure how tall you are. Same thing with shapes there. One of those lines has to be straight. Okay? So, let's do a trapezoid really quick. Let's do one of these trapezoids. Mia, pick the base 1, the top one. Give me a measurement. 10? Okay. Wesley, give me a measurement, not a number. What type of measurement we want? Centimeters, inches, yards, whatever. Okay, we'll do yards. Ozias, give me a base. It's got to be bigger than 10, obviously.
15.
Okay, so 15 yards. And Sharon, give me the height of this. Make it an even number, please. If this is 15, it's got to be less than 15. More than 10. Okay, let's do 12. Okay. I have everything I need because I need base 1, I need base 2, and I need the height. So let's plug in and let's remind everybody what this is. Area equals 1/2 times the height times base 1 plus base 2. Area equals 1/2 times, height is what, ladies and gentlemen? 12. What's base 1 plus base 2? 10 plus 15. So I'm going to rewrite this now. Area equals 1/2 times 12. And what's base 1 plus base 2? 10 plus 15 would make what?
25.
Okay. Just leave it on top. Now, what I can normally do is just do 12 times 25 and then divide it by 2. Or, because one of these is an even number, I'm going to take half of one of them now. Which one can I take half of really quickly?
10, 12.
12, because it's an even number.
There's no 10. Oh.
So, I'm going to take half of 12, which is 6. So, this will now become 6 times 25. Anybody know what that is in their head?
No.
Think of quarters. How much is 6 quarters? 6 times 25. 150. 25 times 6 is 150. So the area of this trapezoid, area equals 150 yards squared. And that's it. So, yes. So the biggest part of dealing with composite figures is figuring out what the shapes are. I'm going to show you guys some examples here. We're going to move on because we're running out of time. So let's go to the homework. For the homework, before anybody asks, you guys are going to do the numbers that are not crossed out. Number 11 is extra credit, if you can figure out how to do it. But we're going to look at one of these questions specifically. So let's look at number 1. What 2 shapes are there right off the bat? I didn't say ladies and gentlemen, but okay. It's a triangle and a rectangle. Number 2, what 2 shapes do we see? Jaden. Not a rectangle. Look at the numbers. That's a square and a half circle, or what's another way? Semicircle. Okay, now I'm going to give you guys a harder one. Number 3, what do we see? So you can't answer. Alex. This trapezoid's here. I have base, I have height, I have base 1 and base 2, so I can find that. Parallelogram right here. I have base and I have height, so I can find the 2 areas for everything. Okay, now let me give you guys a harder one. This is one that you're not in charge of doing, but I'm going to tell you guys right now, it took me a bit to figure this one out. I know some of you guys already know. Okay. Now, looking right at it, you think it's already dissected for you, right? Triangle, 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 rectangle, semicircle. I'll tell you guys right now, there's not enough information. Let's start with the rectangle. It's 4, but it's not 12. 12 is all of this. I need to figure out what this side is. I have no other measurement here that tells me what I can subtract or do, right? I can't find the base for that rectangle. I can't solve that rectangle. Can't solve it as a rectangle. So, that throws a wrench in our plans. After studying it, I noticed this. It's a parallelogram, a triangle, and a semicircle. Everything is here that I need. For a parallelogram, I need base and height. Check. For a triangle, I need height, which is right there, and the base. What's the base of that triangle, ladies and gentlemen? 12. Congruency. If this side is 12 right here, this side is also 12. Check. And for the semicircle, I need just the radius, right? But they give me the diameter. What's the diameter?
5.
Congruency again. If this side is 5, this side is 5, you do half of 5, you have your radius. I have everything that I need to find the area of all of this. So the biggest part of your guys' battle with this on your test is looking and figuring out how to dissect the what's it called? The composite figure. For your homework, again, you are dealing with the numbers that are not X'd out. Numbers 1, 2, 4, 5, and 8. 11 is extra credit. 5 points extra credit if you do 11, but you have to do the other ones first. Are we clear? Yes. 11's not all that easy.
How much is homework worth?
10 points. So please make sure you guys are working on this now. Any questions on composite figures? Remember, this is still a live mic. Okay, I'm going to end the recording then.